Good evening, everybody. Welcome to League of Extraordinary Inventors. I'm your host, Mike from Faraday Research. It is Free Energy Friday. It is Friday, March 6th, 2026. Welcome to the show. Tonight we got Benefactor on, Mr. Ben, and we got Mr. Philip on there in the bottom left corner. And last but not least, we have Mr. BurnEye on the bottom right there. He's still in the U.S. right now doing his travels.
Hello.
Just a show note before we get into stuff tonight. Next week, there will not be a show. My wife's going for surgery next week, so I'm going to be busy with that.
I pray for her successful surgery and speedy recovery.
Yeah, so she'll be out of work for probably about 4 to 6 weeks. So it's a pretty major surgery. So next week will be a scrap. Hopefully the week after I might be able to do a show. I'll keep everybody posted if there's going to be a show update, or if in a couple of weeks I'm going to get going again, and hopefully she'll have a speedy recovery and we can keep the show going as we usually do. If you haven't become a member of Faraday Research YouTube channel, please do so. You can join. I believe it's $3.99 a month, and you get access to over 1,000 videos and live streams, thousands upon thousands of hours of live shows. We've had NASA researchers, we've had physicists, we've had guys from Tesla Tech on, you name it, they've been on the show. So yeah, well worth the $3.99, definitely. So we've had quite a few active members for quite a while now. So I appreciate your loyalty to the channel. Thank you so much for being a member. Don't forget to also check out BurnEye's channel, Crypto Alchemist. And we also have Philip's Fornex. He's also on Finite Energy, right? What is it? Finite
Theory. It's
Finite Theory.
I've got Deep Tech. I'm gonna present to DARPA this month, and I need to prepare presentations for that.
Right.
So
Philip's in the U.S. now. He's been going to a lot of conferences and job interviews and stuff like that. So he's been actively been in California right now for the last, I guess, couple of weeks. Doing a lot of stuff, trying to get incorporated, or you're trying to open a business down there, right? Too.
Yeah, we're gonna open a business in Nevada, and do we open we already have an address in Nevada, and we're gonna register next week.
Me too.
You're gonna register a LLC corporation.
Yeah, LLC. Yep.
Yeah, that's a good idea. Good luck with that, gentlemen. I wish you luck in your endeavors, because that's the first step towards something big.
We're hesitating between Delaware. We're hesitating between Delaware and Nevada, but Delaware is good if you have VCs, and the laws are not gray over there. But we don't want VCs. We're gonna bootstrap the company with C++ superset and grants and stuff like that. it's a it's a perfect timing for us because because I'm part of the DARPA Drone Lift Challenge as well. I'm gonna use C++ Superset to program the brain of the drone. Um, so it's gonna do huge marketing, man. It's like worldwide marketing from the start. So it's gonna give notoriety for our company. So it's
Notoriety.
really good. And I've got the AF Works, the Air Force, U.S. Navy. Like I was saying, I'm connected to them, with them, and there's a government bid website in California. You can bid on a whole bunch of tasks that they have to do. So it's very efficient, and yeah. So we're building the artillery, and my friends are helping me out. So it's really cool.
Yeah, that's good. Yeah, you're really doing a lot out there. And Mr. Bernie's been doing a lot of travels too. He's was at Steve Ellswick's place for the last 2 weeks.
No, a full month I was there. I've been down here for a month and a half. So I did 2 weeks at Nathan's and then a month at Steve's, and now I'm in Sacramento till Tuesday. Then I'm headed to LA where I'm gonna be meeting up with Phil.
So you had question for you. So you had full access to the Tesla Tech archives.
Yes.
Was there anything particular? I know it's a hard question, or to pin it down to one thing, but what was the one thing that you found in his archives that stood out?
I'll show you. Give me 1 minute. And there was actually many ones that stood out. It's just that crazy.
Yeah.
So for one, Steve had the full. It's a golden hardcover book of all of Nikola Tesla's original patents, and then it was updated to get to all of the missing ones that were ever recovered. That was pretty awesome. We're going to be scanning that when I go back there in a few weeks' time, and then I'll show you here. As the freaking dryer works. My apologies. One momento. Oh, there we go. What? What am I doing wrong? All right. Okay. I walk away and it starts. There we go. Okay. What I brought with me that really stood out for my own work and relevancy is. So you might like these, Phil. They might be a little bit relevant to your specific or electrical spacecraft. But for my own stuff, the water fuel cell invention of Stanley
Meyer. Yeah. That was his water fuel cell wasn't his big experiment. It was the coil he made, and that got kiboshed by the U.S. Patent Office big time. They locked him down on that one.
Yeah, it was a Taurus. It was like I think he called it a particle accelerator or something.
Electrical polarization process. Rotary voltage frequency generator is what
Does it show the ionization process?
Yeah, somewhere in here, definitely.
Because that's very obscure knowledge that would be very useful.
Oh, exactly.
Yeah. Well, I made his water fuel cell. I actually made his water fuel cell back.
Electric polarization process, U.S. patent validation report, Stanley Meyer.
Was it Trump's uncle stole most of Tesla technology?
Tesla's death ray and stuff like that. Yes, sir.
Yeah, nine
huge
array,
water fuel cell, electrical hookup. Photo exhibit rotary pulse voltage frequency generator.
And then we have tubular array water fuel cell. And then we have rotary pulse voltage frequency control unit. And that's outside dials. That's inside. We got variable plate water fuel cell hookup, variable spacing test unit, voltage reg. So this
That's
is
good.
an
It shows
actual plot
pictures of the
of
prototypes.
yeah, exactly. It's everything Stanley Meyer ever did, and this is Stanley Meyer gave Steve Ellswick a copy of this himself and gave Steve permission to reproduce them and sell them at his conferences after his brother. So Stanley Meyer gave the copy to Steve, and then after Steve died, his twin brother gave Steve the permission
Now,
to reproduce and sell them. So I think Steve might be.
Bernie,
Yeah.
apparently, Stanley Meyer's brother is hiding in Canada. I found
I've
that
heard
out
that.
after Stanley was murdered. His brother fled to Canada. I believe. Don't quote me on this. I believe he's in Saskatchewan, and he hasn't really
Don't be
been heard of
doxing this
since.
motherfucker on air. Jeez, Mike, come on.
He hasn't been heard of for years. He went into hiding, and you know he's pretty elusive. He doesn't really come out very often. But
I believe that.
kind of like there's a couple of guys that came up with the PAP engine and these high efficiency carburation systems. All these guys basically took all their inventions to their grave because either they got sued, by all the oil companies and conspired. Some of them had death threats. All these guys, anybody who made the internal combustion engine way more efficient than what it presently is, they all disappeared. They were all crushed by these corporations, and I think that's the problem. To perfect even in the internal combustion engine, get 120 miles per gallon. And this was going on back in the 60s and 70s with these guys. So big V8 engines, big blocks, small block V8s. 454s. They're getting ridiculous efficiencies out of these things. But that means selling less gas, less money. So, it's a threat to their bottom line.
Yeah.
It's a threat to the overall control and economy of the petrodollar and current system, but it's collapsing anyways, and this stuff needs to come out right now at this time to prevent World War III and make it as everything's collapsing anyways. They're killing each other, so now we can bring this out and not worry about them killing us, hopefully. Here we got Electrically Induced Explosions in Water by Gary L. Johnson, Kansas State University. Part of it with the water arc discharge circuit. There's so much in it. It's absolutely powerful water plasma explosion. Roy Azevedo, Peter Granule, Charles Millett, and Neil Greneau. Also all part of the patents. It's quite in depth and not
Got a
too
lot of
common
you
or
got a lot of you got a lot of material to go through.
it's absolutely insane. Meyer Fuel Cell Technology, Dublin Institute of Technology. Here we go. Man, there's so much at plot. Okay, so that's Stanley Meyer, and then also very relevant to my own work, we have Brown's Gas, book 1 by George Wiseman. So George Wiseman put together all of Dr. Brown's information and further research on what Brown's gas is, the whole technology and processes and chemical reactions. Absolutely next level. I've gone through about half of the first one, That's book one, and then also book two.
Yeah, he was kind of the one that kind of really got it going.
Sorry?
He was kind of the pioneer of that, the Browns cats.
Missed what you said.
And the other
So,
guy too that
I-
a lot of people don't talk about anymore is the Joe Cell. He
Oh
lives
yeah!
in
Oh my God!
he lives
So
out in
I also have
Australia.
Samuel and Josel books as well. Like he
Yeah,
literally has everything that we've only heard of and it's not been seen in 30 years. It's all in
yeah.
his archives. And
Joe's apparently still alive. Eh?
Sorry?
Joe is still alive.
Yeah, he's in Australia.
Yeah.
Does anybody remember that guy that made that giant Bedini motor?
That was John Bedini built that. He
No,
gave
there
it
was
to,
there was another guy that was replicating his work. He made a giant one and he demonstrated it at like a conference, and then like I think he disappeared.
I know which one you're talking about, Ben, and I'm pretty sure that guy died. Not sure if it was natural causes or not, but it actually ended up APEC of all games bought it up, and I've actually seen it at Jeremiah's place. Jeremiah Pop actually has that remaining device.
Like a replica?
No, the actual one from the guy. They bought it after
Really?
he died.
Interesting. Yeah, supposedly it would put out like enormous amounts of energy.
Yeah, it's absolutely huge. It was crazy. He would never let me take publicly pictures of it, but I got a little bit of video of it that I recorded. It's in my Dead Man's Night. But yeah,
Interesting.
it's there. I was there 6 months ago.
So what I wanted to know, if you've had, I don't know if you've had like interaction with it while it's running, but supposedly it would like get really cool, and there was a problem with
Yep.
it, like getting moisture and getting
Freezing.
like it had like an endothermic reaction.
Yeah. Any magnetic motor or pulse mode DC motor that gets past over unity, its over unity is from an endothermic reaction, bringing the radiant energy down and the temperature down in the room. Thus, it's not violating any of the laws of thermodynamics, and that the force of magnetism itself, we all know, as it gets hotter, it deteriorates, and as it gets colder, it accelerates. So the system gets into this harmony resonance with itself, and then once it reaches that resonance, it starts magnetically superconducting. And it just goes faster and faster, and it gets to the point that you'll get like a frostbite if you touch the device. They get so cold.
Yeah,
Right. It's got a negative resistance.
The exact same is demonstrated in the Searle effect generators. And Mike, you were getting that effect in your pulse motors, I believe, or was it the N machine?
Yeah, my pulse motor, and also I was getting endothermic reactions in my power cells.
Nice.
Yeah.
Very nice.
Yeah, my power cells are endothermic, which I found kind of interesting because there is no redox reaction in my cells. I've successfully created a proper SCI interface in the cell, which is basically the holy grail of solid state batteries.
Interesting. Yeah, I wonder if like you have too large, then the moisture is a problem, but like simplifying it into a smaller form factor probably would solve that.
I can show you an example right now of two cells. One cell is made one way, all right? And the other cell, the one that I've made the breakthrough, if you leave the two cells side by side on the table for 2-3 weeks, the cell that doesn't have that special interface that I was able to create, the magnesium plate that doesn't have it will oxidize on the inside and on the outside. My cells, the ones that I've created this SCI interface, they don't oxidize. They look at the same as they did the day I put it together in an unsealed, unhermetic, sealed environment. So in open air.
Did you look at the investors? Did you look at the investors meeting I sent you by the link?
Yeah, I took a look at it. Yeah.
Where's my forward?
My week's been kind of crazy, Phil. I haven't had much time to really look into that.
We pray for your wife's health and recovery and surgery to go well.
Yeah, that goes on top of the list.
Yeah, exactly. So, yeah, it's been a crazy week, but anyways.
Is it a risky surgery or it's...
Well, okay. Yeah, I don't want to discuss that online.
Yeah, thank you.
Fair.
Yeah, so,
moving on.
But anyways, between the two cells, actually, I'm going to show you. Hold on. I'm just going to show you exactly what I'm talking about. Now, keep in mind, the cells I created were built at the same time. One that has the SCI interface done properly, and one doesn't. So I'm going to show you first the one that doesn't. Take off the background here because it screws everything up. Okay, so this is the one that doesn't have it. See the oxidation on the magnesium plate? All right. Now, they were built the same way, just the SCI and the solid state electrolyte is different. Okay. So almost immediately it starts to oxidize because there's humidity in the air. All right. It's unsealed, completely open, completely bare. When you make a battery, they're hermetically sealed, airtight in a package, so they last. Now I'll show you the proper way. These were made at the same time. Look, there's no oxidation on the plates at all.
Mike, can you highlight your screen, please?
Yeah, just give me a sec here. All right. So you can see there's no oxidation on the plate. Zero. Look at the other one. Look at all the oxidation.
After how long it starts? After how long it starts oxidizing?
Well, this the good one doesn't oxidize at all.
Yeah, so you've eliminated the galvanic destructive reaction out of it.
Exactly. It's gone.
That's the revolutionary breakthrough that Faraday research has accomplished.
Yeah, and there's no electrolyte at all. Solid state. There's no liquid, and I've been able to come up with a method. When you're making the electrolyte, there has to be some water in there. But what's really cool about when I create my electrolyte, when it's curing, all the water gets extracted out. It pushes the water out. And then you pour it off and let it dry, and it extracts more water out and dries it out again. And when it's completely dry, you put it in your cell. So after 2 weeks, there's no oxidation at all. There's nothing on it. Zero. This one here, look at it.
Yeah.
Yeah, that's awesome, Mike, because that's going to disrupt the output that you're going to have from
what it is the SCI interface. Oh yeah, I predict well over 4,000 cycles, no problem. So
what about your dielectric device you were talking about before?
Dielectric device? Oh, what are you talking about? My end machine or what?
Yeah, I remember the to accumulate the energy. So you were talking about the dielectric material.
Yeah, well, yeah. Some of the material is in this cell. There is another material that has to be added to that material.
Yeah.
And basically it would absorb radio waves, any kind of frequency that's in that proximity, it will absorb it. It's like an antenna to electromagnetic frequencies. It's a pretty complicated way to do it. It's like it's almost like you're anodizing the metal with that other element. And after it's anodized, when it sets, it's got to be put on a table that vibrates.
Okay.
For like, I think 2 or 3 days, it has to vibrate as it's curing. And after that, it will pick up anything. It'll pick up any frequency.
Nice.
So
because it's solidifying, so it's creating a bond on. It's building the final solidified bond between atoms at all frequencies between the range of the vibration.
It's going to convert
it'll pick up RF. It'll pick up RF. It'll pick up solar. It'll pick up neutrinos. It'll pick up like pretty much any kind of RF emission. It'll pick it up.
So it's going to convert the electromagnetic waves into energy?
Everything.
Nice.
So potentially it could also be a solar cell.
Well, yeah, any kind of solar radiation.
And a sound cell.
Thermal radiation.
Yeah, the radio. Yeah, the RF, yeah.
RF from a radio frequency, CB system, Wi-Fi. It will pick up everything.
That's wild. Well done.
Yeah. And
I was so
I didn't.
You know, you gotta commercialize your stuff, man. I think, but that's what I think.
Well, this one here, the one we're talking about, I think would be pretty disruptive, and I would probably have some.
Well, the Chinese have announced very similar levels in the past couple of days, Mike. So they kind of disrupted it for you, where now it will be publicly bought by the West and acknowledged and bring us back up to par. So you're at the perfect timing and space.
Put a big bullseye
on. But you know, one thing I learned the hard way is if you open source everything, people like Brandon Berg are just gonna plagiarize and take credit for what you did. This is exactly what happened with the
more than anyone.
Yeah, but that's been going on for a while now. It's just like almost common.
And all of APEC, and sending it to Lewis.
Yeah, they're clearly watching your show, man. I just barely talked about DARPA 2 weeks ago, and last week I heard Brendan Berg bragging about doing business with DARPA. It's like, geez.
Well, no,
so
Brandon Berg actually worked for DARPA for 20 years, and he's been allowed in the last 2 years by DARPA to start publicly bringing forward his past work from a couple decades ago. So it's Brandon Berg's case. It's not he's ripping anything off. It's just they've finally given him permission to go forward with the work that he did for DARPA a couple decades ago that was just been classified since.
But he did the theory. Just the theory.
I'm having him at Tesla Tech, so.
He just did the theory, not the experiment. But since I'm here to confirm it,
you must have missed his last presentation. It was on Tesla Tech that he did it, not APEC. That's why you wouldn't have seen it. Check out the last time he was on Steve's Place podcast, and he goes over all of it, and that was a few months back.
Bernie, I meant to ask you, is there a chance we can get Vernon Roth on again?
Sorry, say again?
Is there a chance we can get Vernon Roth back on again?
On this podcast? Absolutely. We're planning on it.
We should try to get him back on soon.
100%. And if you want to interact and have in-depth, in-person conversations with Vernon Roth for all 5 days, you need to come to Tesla Tech. And not just him. There's Bob Green here. There's Ludwig Thorsten. There's going to be Dr. Yu. Terrence Howard's coming back. We got Nathan coming to present. We got Parker Edmondson coming. We have
that rings a bell. The actor guy, what's his name? You just said his name.
Terrence Howard.
Terrence Howard. You were supposed to get him on your show. That never happened. What happened with that?
It was issues. So that's one of the other things I'm going to be working out in the next few weeks in LA. Is finally meeting up with him, and the issue is meeting up with his media management team and working out the contract with them, because as a actor and all the fucking legalities of his the rights to his stuff, that they have to approve it, and it's got to be approved in certain manners, and that's been the holdup.
He's part of a union. That's why.
Yeah, as well as his manager and all the previous contracts through management and stuff like that. There's a lot to it. But it's mostly that they have the legal contract is his media management team needs to be able to review what the project is, that it's in line with everything they're doing, that it's like in the image of what they're working on, sort of thing, and approve it is the main thing.
Bernie, I'm just gonna deke out for a quick smoke. I'll be right back.
Okie dokie.
Okay.
Sorry, I lost connection. It's not my laptop. It's just the Wi-Fi that is flaky.
Gotcha.
Sorry, I missed what you were saying, Bernie.
What was it talking about?
About LA?
Just why I haven't been able to record with him yet. But that's one of the things I'm going to be doing while in LA, is meeting up with him and his media management team, that in his contracts, anything he does has to be brought forward to his media management board and approved by them, that it's in line with all the rest of the stuff that they're working on and what he does, sort of thing. And then then it can finally be done. They just have to sign off on it.
Okay, cool. So you're not gonna waste your time here, that's for sure.
No, gosh, no. I'm doing so many different things. It's wild. Very, very busy and getting so much done. Lots done, and more, exponentially more to come as it's go down back to LA and Southern California in the coming week.
Yeah. Welcome to SoCal.
Hey, do I have to remind you, Phil, that I beat you down to SoCal by 2 weeks at Nathan's? Okay, so I'm just returning to SoCal, and you copier guy, you beat me by 9 years or 20 years or so.
Yeah. You beat me by 2 weeks, that's for sure. I was
But you're
frozen, I
returning
guess.
to where you used to be in San Diego
Sorry?
earlier in your career. But you've been down to based out of San Diego before, right?
Yeah, I used to live there for 5 years.
See, you beat me by at least half a decade.
Yeah, that's why I got friends over there, and right now they're helping me incorporating the business and all that stuff. So it's really cool.
That's amazing. We're creating a super team as we all meet up in person and bring our projects together.
Exactly. Let's connect the dots.
Agreed. And sell a portion of it to the military for a large sum of money, but not close to everything.
Yeah, exactly. Not. It's a hybrid process. You open source part of it, but you want to make, for me to prevent war is to have the best technology by deterrence. Nobody will want to fight you, so I think that's an approach, not to have any war. So that's my logic. It's not.
It's a noble.
It's not because I'm in touch with the military that I'm pro-war. It's totally the opposite.
That's a very noble and moral choice that you're making there. You know what I mean?
Yeah, because people think that you're with the military, you want war, but it's exactly the opposite. So that's my plan, is to present my stuff by the end of the month, my 3 technologies, and the stealth propulsion, I need to I've got a theory to optimize it to maximize the effect.
I can probably help you with that, but we're gonna have to sign some legal things.
Yeah, NDA or something like that. And
yeah.
The other two is the electromagnetic, the force fields or the deflection system, and the third one is the exotic antimatter genesis.
Yeah,
So
that's the one I'm a master of, and literally thousands of years ahead of everyone else.
on antimatter, cool. Okay, sounds interesting.
Exotic materials and metamaterials, and some quasi crystals and stuff. Not necessarily sure it's antimatter per se.
Oh, okay. Um,
But
yeah,
I do know, I do predict how to make that. It's just combining a couple more magnitudes of energy processes into it while the reaction goes on, and it should actually do what you're talking about. But part of the reaction will be radiation and time radiation decay that you don't want to be around it while experimenting and figuring it out. And yeah.
yeah, because you need safe equipment and a lab and all that. Um, yeah, so
Exactly.
so I'm about to sell my software as well. So the demand is pretty huge already. I got metrics. I'm gonna go to the NVDA GTC conference in San Jose March 18. There's gonna be huge, and
When is that?
in San Jose
No, when?
March 19.
Oh, okay, right away, right away. Can you get me an extra ticket? Can I be your +1 / row date, brother?
Yeah, I wish, brother, but it's pretty expensive, the tickets over there. I just go there for one day because 4 days is like $2,000, So I
Oh,
just go there
that's
one day.
wild. That's crazy.
Yeah, it's crazy high prices, but you're on the top of the pyramid, so you meet like the most important people on the planet from the start.
You should.
So
You will find a way to bring me with you.
yeah, I'll open the dude. Just stick with me. I'll open you the back door. Very simple.
Absolutely. I will bring a ladder with me, and we will have a work vest, and I'm gonna walk right in.
Sounds like a plan.
Wouldn't be the first time.
Or you dress as a waiter or something like that.
Well, as a construction person on the outside, and then underneath that, you have the full dress suit or whatever that you just strip off, and you immediately abandon it as soon as you're in and not in the sight of camera, and you're good to go.
Exactly. Yeah. I think I'm gonna go outside, so just stick with me. Yeah.
Yep. We'll be here. We're not going anywhere.
Okay.
Phil, what was the conference name again?
It's a NVDA GTC.
ETC. You're cutting out right now.
Yeah, don't move.
Sorry, I'm cutting you off.
I can hear you now. Can you repeat that? Sorry.
Yeah.
Was it the
GTC.
ETC? You said?
GTC.
GTC, and what's that stand for?
GPU technology conference, something like that.
Oh,
It's about
okay. I get what you're saying there. All right.
yeah.
Very nice.
Yeah. So if you can make it, that would be great.
Yeah, I got some new components. I'm gonna build a circuit for my cells. I got a couple ideas. I want to try and maybe hook it up to a jewel thief and see what I can get out of it.
Nice.
So
definitely update me on that one. I'm interested in anything related to the jewel thief.
Yeah, like I like to get my cells and then hook them up. Each cell is actually two cells for one.
Mm-hmm.
So that'll put in about 2.5 volts to 3 volts. The two cells put together, that's one cell. So I'm gonna step it up a notch. I want to order some new material. Actually, I want to put graphene in my new prototype. So I've got the electrolyte or the solid state part anyways figured out. That's done. I know how to do it. I know how to make it effectively and reliable. Now I don't have to worry about the magnesium anode deteriorating. I know that will last for years, especially if I seal it up.
Yeah, the magnesium is very reactive at a certain state, and a very small but steady fraction of the magnesium turns into radioactive isotopes out of the reaction as it breaks down. If
Bernie, did I tell you I was picking up a little bit of a radiation reading with my my meter?
You did not, but that's what I predicted, and
it picks it up.
Yep.
Okay, so listen to this. This explains the difference in power.
The Geiger counter, right?
Yeah, my Geiger counter. This explains the difference of magnesium's energy density compared to lithium. So it says magnesium batteries offer a higher theoretical volumetric energy density, up to 3,833 milliamps per square centimeter, compared to lithium, which is only 2,062 milliamps per square centimeter.
Yeah, when you go into the atomic molar mass, like the density weight energy, it shouldn't be that big of a difference, right? But it's because of the nuclear decay energy activity within it.
Right. So that's why magnesium's over 1,000 milliamp hour per square centimeter better, allowing for compact, dense storage, but have a lower theoretical gravitic metric base energy density of 18.8 megajoules per kilo versus magnesium with only versus 42.3 megajoules per kilo for lithium. So lithium has a little bit of a gain there. While lithium currently holds a higher practical energy density, magnesium offers superior safety, lower cost, higher volumetric efficiency, potentially reaching 100 watt hours per kilo for further development. So
you got like I'm sorry, go ahead.
That's the reason why I'm using magnesium. Energy density, lower cost, and also safety.
So with the magnesium, you can make it smaller, is what you're saying.
Yeah, you get more in a smaller area versus lithium. Now, lithium has runaway issues, so you have a heating issue.
Right. That's a common problem.
Exactly. Right? You got it.
You got dendrite
and what you solved, Mike,
yours is safer and more stable.
Risk and danger of the magnesium galvanic reaction is where the small portion turns into the radioactive isotope. Since you've
I don't
the galvanic reaction, that's why you don't have that.
Yeah, I don't have it because I'm in a solid state. I don't have the redox reaction that normally you have.
Exactly. That's why you revolutionized it.
Right. So now I've taken the water. So basically, when it comes to batteries in general, water is the enemy. Water is the enemy in a solid state
Well,
battery.
the galvanic reaction decay specifically. Once you get the water into a liquid crystal harmonic resonance state and the proper coatings, nano coatings, for instance, like the graphene and stuff like that, preventing it, and your gel and several other things, then it can be okay. Eventually,
right. But
we'll see. That's what I predict.
The interesting thing is with magnesium, if you have a redox reaction happening, what will happen is it will produce magnesium hydroxide, and you'll actually smell it. So
exactly, right. That's the other part, is that a certain, depending on the metals of the reactions, certain amounts of that reaction can turn into toxic gases, or different isotopes, different molecules. There's so many different risks.
So all of those things that we've been talking about, I've experienced in my research in the last 2.5 years building this stuff. If you have a redox reaction, and you're going to have magnesium hydroxide byproduct come off at a gas. All right. This is what you don't want. You don't want this. Very important. So in the 2.5 years, I guess the moral of the story is water is the enemy to a battery. Simple as I can put it. If you eliminate the water in a battery and you can make it work, that battery will last for years and years.
Exactly, solid state.
Yeah. So Solid State Donut just did some preliminary tests with their solid state battery, and they had some really, really interesting results. They were able to heat up the battery up to 100 degrees C and keep 98% efficiency of their cell. Yeah.
That's crazy.
Nobody's at 100 degrees C. Lithium.
That's wild.
With lithium, if you did the same thing with the lithium cell, you would have
the runaway reaction and explode.
You would have a blowtorch. Yeah. So this new cell, under harsh conditions, has been able to perform at 98% efficiency at 100 degrees C, which is quite impressive by manufacturing standards. That's actually unheard of. Now the other tests they're going to do in their second wave of load testing is going to be at minus 33 degrees or minus 40 or something like that. So they're going to do a cold test as well. So I'll find out the results of that probably in the next few weeks when they actually do it. So, when this donut solid state battery company came out, everybody said, it's BS this, BS that. And then they put out this report and they're going, holy crap, this is real results. And no other cell has been able to actually do that. So they're saying 400 watts per kilowatt hour output, which is like 300% over everybody else. I think CTAL in China right now, their best battery puts out 175 watts per hour. So this is quite a bit higher. 400.
Yeah, that's crazy.
Interesting stuff. So
talking about water, did you see the article I posted at some point that you can get lithium out of ocean water?
Yeah, everything's there. Gold, lithium, magnesium, everything's in water, in ocean water. Everything is there.
Yeah.
Interesting.
Why do you think Tesla used the ocean as the ground? Like Wardenclyffe Tower, he had a copper bus grounding system that was like over 2 miles long. He used the ocean as the ground.
Oh yeah, wow. So he knew about it already?
In the 1800s, he knew it. We're going back 1890 here when he was in Colorado Springs doing all his experiments out there. And then when he started building the tower out in Wardenclyffe, he made a massive copper bus system in the ground, because that's how his system actually worked through the ground.
Yeah.
He connected the earth with the ground through his system. And he could broadcast that energy anywhere on the planet. So what he did in his experiments out in Colorado Springs, that told him it was physically possible to do what he did, was he set an impulse wave out, went counterclockwise to the earth, and then he received it like a minute later on the other side. He was able to send a signal all the way around the planet, come all the way back, and receive it on a second antenna behind him.
Nice.
So he used like a directional impulse. So it was going in one direction. So he sent that impulse out and received it behind him with a receiving antenna behind him. So he knew he could send energy right through the earth, through the atmosphere, come all the way back around the planet and receive it on the other side. And as soon as he got those results, he says, it's time to build Wardenclyffe. And that's when he moved back to New York City. So
that's really cool.
Yeah, that's neat.
So, and you know what? It just kind of baffles my mind. Back then, he didn't have transistors. He didn't have, modern day capacitors. He didn't.
He built everything by hand.
He built everything by hand, capacitors, all that stuff, copper bus, everything was all.
He made his wire by hand. Yeah, that was insane.
Like, he didn't have the luxuries of what we have today for materials.
Yeah, if he had access to our, if he had access to our advances in material science, man, today,
he would. They wouldn't allow him to do anything. They would go after him with a pitchfork.
They put him on an island and ban him from the rest of the world.
Yeah, they would put him in total isolation. Oh, for sure. If he was alive today, my God, the stuff he would have been able to do.
Yeah.
He was right at the beginning of all this stuff coming online. Transistor didn't come out till like almost when he died, right? So stuff like that, he didn't have all this modern day electronic equipment and switching devices. He didn't have MOSFETs, so he had to use rotary spark gaps for his Tesla coils.
Right. With the spark gap, it does an amazing job supposedly at switching. So,
well, because it's using the spark in its natural state. It's not being manipulated by a transistor or a MOSFET. There's actually a discharge.
So there's no impedances.
Right. So, because like in my Renegade, that's why I use a spark gap switch, because I know the second that spark happens, the basically the draw or the current pull from the battery goes to zero.
Wow. Yeah, there's no impedance, there's no loss.
Right.
That's
right.
Awesome.
And because the battery is sluggish, it doesn't have time to react to that. It's not an instantaneous pull. Like when you pull a battery, it takes a couple of seconds for that battery to react and give you that current push.
That's true.
When you use a spark gap and you release it before it's ready to push, it releases the signal or the power potential, and then the current goes to zero again. So if you get it timed just right, and I've done it with the Renegade, I've run my Renegade on dead 9-volt batteries, and it will run for months.
Yeah, and you're running a lot of light bulbs with what wattage light bulbs are those that you see on your panel?
It's a total of, when I hook it up to the watt hour meter directly to regular house power, it worked out. I think it was 46 watts. It pulls
46 watts.
46 watts.
Yeah, there was I see your panel. It's got like at least 6 or 7 or something like that.
I got 8 bulbs, but they're different. Yeah. Some are 9 watts. Some of them are 6 watts. I got a mix of bulbs, but when I put it up to the watt hour meter, you want to see how each
one reacts, right?
Right. I could turn it up. I put one bulb on and see how it goes, and then turn the next light on one by one. Right. That way I could see a gradual climb in, resistance on the system, and you see how the motor reacts to it. And I've engineered it. It doesn't matter if you pull 100 watts or 5 watts, it has no effect on the motor. Where most
you don't see
any
drag or anything.
There's no cogging, no drag, that doesn't exist with my Renegade device. So it doesn't matter what you pull off it, the motor doesn't see it. It doesn't recognize it. It just keeps chugging along, doing what it's doing.
Wow.
So in that way, you're not killing a dipole. If you kill the dipole, well, Tom Bearden talks about this all the time. Leave the dipole alone. There are other means of pulling power off that system without killing the dipole. If you understand his concepts on how to do that, and I figured that out, a few years back, I could pull as much power off that Renegade and it would never cog it. It would never short out. It wouldn't get pulled down where a regular conventional motor would be burning up.
Right? So what's your method of diverting the current from returning to the source? Or
what I like to do is add it to a second coil on that on the series circuit into an isolation transformer. Okay, at the isolation transformer, you're basing the transfer of power by magnetic field, not by actually pulling physical electricity off the dipole circuit.
Right, you're letting the reaction between the fields do the work.
That's right. So when you do that, there's no cogging of the wheel because you're getting your potential at that isolation transformer. Oh. And from there, that's where the separation is. And then after that, I put it through the full weight bridge rectifier because it's a lot of the Renegade creates transients, huge transient spikes where everybody says, you're losing power here. You're losing. No, I'm not. I've created a dynamo is the best way I could describe it. A rotating dynamo, and you just pull off it. You just pull off the dynamo without affecting the dynamo itself. It keeps
exactly because you're not breaking the dipole, because you're not having to create and destroy an electromagnetic field. The magnetic field is a constant. It's not requiring energy to recreate it and destroy it twice in a cycle. It's just a full cycle with no energy required because you're not breaking the field.
Right. So I've also figured out, because people say, can you loop it? Can you loop it? It makes me go loony every time I hear about it. But I said, fine, I'm going to loop this thing. I'm going to show you guys how to do it. And then I don't want to talk about it no more because I have other things that, in the circuit. So what you have to do after the isolation transformer is you got to break the symmetry of the energy. And this is another Tom Bearden thing. When you break the symmetry of the energy, now that energy doesn't know where it came from. So you put it through a full weight bridge rectifier, put it through a nice large capacitor like this blue one here. It's like 60 volt and 16,000 microfarad. I dump it into this. And then from there, I put it through another bridge rectifier because you want to change that symmetry of the energy. You want to smoothen it out. You want to make it pure again. And then after that's done, I could basically reroute it right back to my battery that's running the Renegade, and it doesn't short it out. If you don't do it, it will short out, it will slow down, and your wires will heat up, and your coil will
becomes parasitic, resistance,
and then you'll smell smoke. So that's what you do.
The difference between a hot current and a cold current electricity, in that it can pass through with zero resistance.
Yeah, and what I like about these capacitors, these guys are like self-healing. These things could take a lot of punishment. I have other ones that are larger than this. They hold like 2,800 volts DC, and they're oil filled, and they're you could do some interesting. I want to do some high voltage stuff. I want to do some atmospheric electricity this coming up summer.
Oh yeah,
So,
we should do a
so
private video call sometime in this week, Mike, and discuss some things once I'm back at Nathan's.
Yeah. Hey,
So,
but by the way, guys, I gotta go because I need to prepare a presentation for the tomorrow morning actually. So
Yep.
I need to
Shit,
start working on
regularly
that.
Quebec Phil would be passing out by now. We got American Phil, and he's so inspired he's working on Saturdays.
Good luck with your presentation, Phil.
Yeah, thanks. Hey,
Not
Yeah,
dead,
good luck.
buddy.
see
I
you
look
next
forward
week,
to seeing you
Bernie.
on Tuesday, my friend.
All right, please don't bring MIBs or anything. Just you.
yeah, really.
All right,
Much
cheers.
love,
All
brother.
right.
Good luck.
Thanks.
All right. Good luck, Phil. Take care.
Thanks.
I'm just going to mention I did cross a few very, very rare Tom Bearden papers and books at Steve's place, but he would not part. He didn't have any extra copies and he would not part with them, but we are going to be scanning them when I go back there before sometime in the
Take
next month
pictures of
before I
them.
return. So I will get you copies of it.
And what is it about? What we were talking about, or?
I didn't get a chance to go through them. I just set them aside in Steve's do not fuck with secret archives section.
Yeah. So yeah, that'll be interesting to see what's in that. But
It's actually insane, Mike, what are in those archives. Like it's literally like at least 50 years of every single revolutionary inventor's full patents, papers, and books that he has. Like everyone that was murdered, everyone that died and stuff, they all worked with him over the years, and he got copies of all of it, everything. It's nuts.
Yep. Oh, I can imagine. Well, he's been around the kind of the golden age, right? He was there, probably.
Yeah, it's the
early.
41st year of the conference.
Yeah, so we're talking like 1983, 1982.
84. 84 was the first.
84.
1 year before
84.
I was born.
Yeah, I was born in 73, so I would have been 12. Yeah, 12 or 13. Yeah, 13.
Nathan calls himself the old man builder, but I guess
I got a few years on the old man.
Private conference event organizer and runner than a physical builder these days. Otherwise, I'd be like, it's Steve, that's the old builder. But yeah, it's up to us younger ones.
Well,
Nathan is young.
I'm the old man. I'm the true old man of this group. Yeah, I turned 53 this month. I'm the old man of the old man builds.
Happy early birthday.
Yeah, it's not till the end of the month though. 25th is my birthday. Yeah, so Ben, what's been going on with you? I see a rodent
Sorry,
coil.
just need a moment here. I'm hopping onto the Wi-Fi instead of my cell phone.
Yeah.
So I got a couple of things I'm working on, as well as continuing to condition a battery with negative electricity. It's taken a long time, but we've tested it out. It's on cycle 3 right now, but it's taken the negative electricity pretty well. Creeping up there closer to 15 volts, getting higher and higher every cycle. So, and then I noticed on discharge cycle, a portion of the cycle, it's how Bedini described. We're starting to see like the shelf where like it reaches like, say, 12.4 volts on the discharge, and it just stays there for like a long time.
Yeah. That's good. That's good.
Yeah. So it's not fully conditioned, but it's getting there. We're gonna have to do like 20 or 30 cycles. It's gonna take a while. Then we'll run that on the Wattman test and see what happens. But I also have a couple of things I'm going to show you. I'm going to pull up the lab cam if you want.
Sure. Yeah.
Give me 1 second. I'll bring it in.
Cool. Yeah. So I have some materials. I ordered a whole whack of different diodes. So I want to do some isolation of my cells using diodes. So I got
high speed ones, or what kind of we were working with?
I got everything.
A variety.
001, 03, 04, 05, and I got a few Schottky diodes. I got N5817, 5818, and 5819. And
nice. Yeah, those have zero recovery. That's good to test.
Yeah. So I got a good mix of the N400 series, and I got a good mix of 3 different Schottky diodes that I can experiment with and see how that works.
Nice.
Yeah, so I got those. It's like a pack of 100 of them. I got them for like $13. Yeah, so yeah, right on. We got something to play with now.
Mike, do you mind highlighting my screen for a second?
Highlighting your screen? Yep.
Anyone have any idea what sort of metal this might be? As it's very heavy, and even has magnetic properties. But not iron because there's no oxidization.
Dude, good question. I'm not sure. Is bismuth? No, bismuth is
No.
non-ferromagnetic.
Yeah, it's
I'm trying to think. It would have to have some ferromagnetic.
Monopolar, is it? Or the one that repels magnetism?
Well, bismuth, yeah, diamagnetic.
Diamagnetic. Thank you. That's the term.
Yeah.
Yeah.
So it would have to have some kind of steel ore. Magnesium is not magnetic. I don't think magnesium is magnetic. I'll have to double check that. Oh, yes, it is magnetic. Yes, magnesium is magnetic. Magnesium is magnetic. But if it's exposed to water, it would oxidize right away.
It's in quartz veins, it appears.
You might have some mic in there. It kind of looks flaky. It's shiny. I wonder if you got some silica in there.
Very shiny, very heavy. And then
silica
got interesting cleavage and crystal structure formations. Very heavy.
Yeah, I would have to actually see it right up. There could be some stuff that has some silica in there.
Well, yeah, there's definitely the silica with the quartz veins, right?
Yeah, there's definitely quartz in there. How about iron pyrite? You got any iron pyrite in there?
Pyrites, it's too dark and gray to be pyrite, and it's a different geometry of crystal structure. Pyrite's usually cubic.
Germanium.
Could be
germanium. If you found germanium, oh my god, that's
apparently it was extremely coveted by this the individual that had accumulated it or got it, and then he passed away, and it was left in this house, and
the shiny. Okay, so the shiny silverish material you got there, the stuff you were just showing, I would get that maybe checked out. That could be germanium,
right? Like it's some sort of very rare metal element.
Or if you have know anybody who has a metal detector, that would be good. Yeah, you might have some germanium
spectrometer. Yeah.
Yeah, that'd be kind of cool to find out what that is. Definitely is some silica.
Right? Very, very fascinating. So it's
Yeah,
kind of
W.
hexagonal in its crystal.
Yeah.
6-sided formation. Oops. Where like something like bismuth is tri or cubic. Yeah, very very fascinating, strange stuff.
Yeah, if you have a magnet, find out what stuff is magnetic and what stuff's not magnetic, and divide.
Yep.
Put them in a different jar, and
I'll
then try
follow
to
on
sort
that.
them out. Sort them out.
That was my next step. I just didn't get to it yet today. But bang on.
Yeah, that's kind of cool. Yeah, you might have some silica. There's definitely some silica stuff in there for sure. That'd be a
Oh,
real
100%.
cool if
You
you
can
had
see all the
germanium.
quartz veins. Interesting stuff.
Yep, that's cool. Cool. Yeah, I like stuff like that.
Yes, sir. And I'm gonna try and use some of it as electrodes, as anode and cathode, and see what happens. Get real interesting, real quick, possibly.
Right on. Yeah, definitely got some ferromagnetic stuff. Iron. There could be some stuff that has iron in there, possible.
It's not. It's definitely not iron because it's um there's zero oxidization whatsoever, and also it's way too dense and heavy.
Yeah. It could be some lead in there. Definitely lead
I
is
was thinking there's potential lead within some of it. Yep.
Yeah.
As a possibility. But I think it's even harder and denser than lead. It's either one heck of a crazy alloy or a couple rare earth element metals potentially.
Yeah. I heard some people like finding, like meteorite rocks on the ground. And they were talking to one of the professors from the university. And they said there's actually people who go out looking for rocks. And then if you suspect, something might be like a meteorite or whatever, he says, just take a magnet up to it. And if it grabs the magnet, chances are it could be from outer space. And universities actually will pay money for retrieved meteorites. And
that is actually a possibility in that some of it seems like it's melted on the outside on one side
that
of
would
it, and then
explain that.
on the
Yeah,
other
that would
side.
explain the silica. Yeah, like it was superheated, and you had the silica,
Right?
the crystallization on the outside, and then you have the bare metal on the inside. So, interesting. I would take that to a university. They might be able to test that and see if some of it could be from meteorite, right? Because they come in all shapes and sizes and stuff like that, right?
Yeah, so this one you can see it's based off of a hexagonal crystal shape.
Yeah, bring it down a bit. I can't see it.
All right. And then I was going to show we got the Joe cell in one of Steve's extraordinary science and technology magazines, and it's the hydrogen generator HHO free plans inside, and we got the actual full plans for one of the Joe cells in one of Steve's magazines. It's absolutely insane the amount of just knowledge and technology that are in the Tesla Tech archives. It's mind blowing. Mind blowing. And then there's also the Geeks
single auto conversion plans. This information is classified as experimental. That's how you turn your vehicle into a GEAT generated vehicle.
Yeah.
Air management valve.
I think the original guy who came up with the Geet engine, I think he died under
Oh yes,
interesting
absolutely.
circumstances. Yeah.
Yeah. So Steve was actually raided by the FBI in the early 2000s because of all of this. But then he was able to sue them on technicalities, and they had to leave him alone, and he got some stuff back, but they took his computers and they gave it back with a whole bunch of spyware in it, and it set him back a little while.
That doesn't surprise me, at least.
Oh, and it was very tragic. I have to give a shout out and announce the passing of Terry Wolf. Terry Wolf was Steve's silent business partner in running Tesla Tech, and he passed away just, I believe it was on Monday, and very sad. But they actually targeted Terry when he first started partnering with Steve, and he ended up doing, I think it was 5 years in jail unjustly because just suppressing him for working on this stuff.
That's crazy.
And then even the judge that was their former judge, then lawyer, legal representation that was their friend that took on the case to represent Terry, they also then charged him with bogus things and put him in jail along with Terry for those 5 years. And just it's absolutely insane the amount of suppression and attacks that they've been doing forever on anyone trying to bring this stuff out. Here we got one of Stanley Meyer's actual news release pieces, and on this one, we got the actual full water fuel cell that he didn't really. I've never really seen these designs before anywhere, so it's just wild.
Huh. Yeah. See, that coil is the one that they seized. That coil thing that you just showed, that's what they seized.
Oh yeah, for Stanley Myers, absolutely.
Yeah.
There's for water atoms, thermal explosive energy, hydrogen fracturing process, and then we also have water fuel cell flow diagram, laser drive system, magnetic spin generator, high frequency pulsing transformer, electrical pulsing generator, electromagnetic drive system, mechanical drive system, regenerative energy feedback, EPG, gas actuated electrical generator, inertial combustion electrical generator, fluid drive electrical generator, electric polarization generator, electrical mechanical output, and it's the full system.
Wow. That's crazy.
Indeed.
Yeah, it's great you have access to that.
Right, and we're going to be digitizing and preserving and making public all of this. Well, at least half of it's going to be put public, and then the other half that Steve has the rights for will be for sale for copies of it. But I'm going to encourage him to put a lot of the very suppressed stuff out that was claimed to not exist, and it's been like many of them a decade, 2 decades since the actual inventors have passed, and it's time that lots of these information needs to get out there.
Yeah, that's cool, man.
Got Tesla's engine.
Oh, did you? Oh, I meant to ask you. Did you come across anything from Howard Johnson?
Yes, sir. There's several of his presentations, and I believe one or two of his book patents. Bruce A. Perot.
Yeah, Perot. Yeah, he's good. This guy is good. I've seen a few of his conferences. Yeah, he knows what he's good. He was at many
Plasma
of the
oscillation.
Yeah.
Ooh, radiant energy research. It's literally the Library of Alexandria of breakthrough technology and free energy and anti-gravity. High voltage power inverter for alpha fission. Ooh, high voltage power inverter for alpha fission. Interest. Okay. Very clearly relevant to my own work and what I was setting up next, and am setting up next. That's why Steve gave me this one specifically. All right. I like it.
Like a kid in a candy store, right?
Right? Ultimate nerd experience ever. Neutron oxidation reduction. Oh, wow. It's all my work. Done by someone else 3 decades prior. I love it. Because it's like everything I've come up with that I was about to experiment with next by myself just confirms it right here. Amazing. Safety procedures must be carefully observed, or you're gonna right, exactly.
Mr. Ben wants to show his lab stuff here. Let's
yeah, for sure.
Quickly to
Ben, take her away. We would love presentation updates.
Give me 1 second. I'm gonna bring up the lab cam. All right. All right. Cool. It's working.
Yeah, it's working.
I'm gonna have to use this mic.
Yeah.
So I'm gonna turn it up as much as possible. All right. So I have this Starship coil with magnetic rotary.
All right. Cool.
And what we're going to be doing with this is, so I basically got this on sale. Here, let me take this mic over to the table. I don't know if it'll stretch. But I basically got this on sale. It's usually like around $80, but I got it for 40 because I needed the magnetic rotary assembly. It probably has a standard PWM pulse width modulator, some similar circuit on the bottom, but it utilizes this with a pretty low input requirement. So it spins it at 4,200 RPM with only 2.3 watts of input, which is interesting.
4,200 RPM.
Yeah, that's what the tachometer picked up.
And you're only putting 2 watts in. That's pretty good.
Yeah, 2.3. Yeah, that's what I'm saying. It's pretty efficient. I don't know if it's probably not over unity, but it's very efficient. Now regarding picking up with like a Rodin coil as a secondary, we're only able to pick up maybe like a watt of that. So I'm thinking maybe the driving needs to be with the Rodin coil, and then we'll try to pick it up with a Starship configuration. I wanted to test this in different ways, like using the Starship as a driver and then a pickup and vice versa. So, but not with this circuit. The circuit doesn't seem to be right for what I'm doing, specifically because it doesn't seem to be wound in both directions, right? It's just one direction.
Right.
So we're not able to produce like a monopole. So it's still got the drag from a regular, magnetic rotary. Yeah. So but right now, before I tear it apart, I want to.
Can you get closer, Ben? Ben, can you get closer just to get a better view of it?
Yeah, I'm gonna start in a second, but before I tear it down, I wanted to kind of test it, test its efficiency and get a baseline for it, But I am thinking that the starship or the star pattern, at least the 2D rodent coil pattern, could be like similar. The field could be similar in shape to like the inverse of the rodent coil, the Abha coil, whereas the magnetic flux is contained in the center of this one. This one I'm thinking might be like kind of like a pressure valve, where it's not condensing it in the center but spewing it out the top and the bottom.
Right.
So that's what I'm thinking. I could be wrong, but we're going to be testing with that. And also I'll show it to you in a second. We'll start it up. But I also got the speaker. This coil, the fireball coil, unfortunately fell, and I have to redo the wiring because it wasn't soldered. But I am going to test it on the Mark I to see if we get any effect. But it is basically just a speaker, and you can see like it just fits in the center here real nice. It's got the magnet.
And it starts bouncing around when you hook it up?
We haven't hooked it up yet. Tonight will be the first time I tested it out, because this fireball coil is the only one it fits nice in the center of, and the fireball needs some work. It fell, so I need to rewire it. But we will test it on this one. It won't fit in the center, but it might pick up some kind of, effect. So we'll see. But I'll show you the magnetic rotary first, the Starship coil, and then we'll test the speaker real quick.
Great. Sounds good.
Microphone on so you guys can hear it, because it's got some power to it.
How much current does it draw?
You said I actually didn't measure the current. I just have it hooked up to the Wattman meter. So when I hooked it up to the Wattman meter, it was only pulling 2.3 watts from it.
Okay.
So we just give it a little spin and then plug it in to the battery. You can hear.
Yeah, it's fine.
It moves, so I gotta like pin it down.
Interesting.
Yeah, well, let me get the tachyometer out and see if because sometimes it doesn't pick it up. I've tried to put markings on it. Actually, you know what? I have to put tape on it for it to work.
Yeah, like a silver.
Yeah, that's how I got it to work. Now, let me do that real quick so we can take a reading. Because last time I took a reading, it was like 4,200 RPM.
Right.
Man, that's some amazing work, brother. Like, I just listen to everything you're saying and showing, and next level, 4,200 RPM. That's pretty good for only 2 watts. And I think it's anything over 4,000 RPM. That if you have monatomics or low energy plasma state matter going, that it'll actually activate the ionization field and ionize that matter from the spin.
Nice. Yeah, no, we're going to take a reading here. See, last time it was 42. Yeah, 41.
4,100. Wow. 4162. Yeah, that's pretty awesome. Yep.
Yeah, 4189. I think that's it's upside down, but
yeah.
So
it's awesome, man. I didn't know a Starship coil can make a thing spin like that. So that means the field is spinning, going up from the table and down into the table. It's spinning like sideways. Like if you stood it upright, then it'd be spinning around in a circle. But
yeah, I think you're right.
So that field I'm wondering
at a
if you put
perpendicular, right?
if you do you have a electromagnetic Tesla meter?
I got a pole detector.
No, a frequency meter that'll pick up any like
no, I don't have a Tesla meter.
flux.
I got a pole detector. That's about it. But that's not going to show us anything when it's spinning.
Yeah, if you had a Tesla meter, it would
It'll
be
show
spewing
alternating.
out flux. Because I know I get about a 2-foot field around.
I got to use my laptop to input that frequency. Hold on. Let me grab the laptop.
That's cool. I never seen Starship Coil do that before.
I actually have when it's in the right geometry and right number of spikes, right? Like when you're in the 12, I think, and I think in like metrics of 9s and 3s, I think it creates it, but I could be wrong. But I've seen a couple demonstrated when done right that do it every time, and then there's the ones that are just one number off, one extra like extra point in it, and then it's instead of being a sustained smooth rotation, it turns into a static jumbled scattered mess of all over the place, and shards of field everywhere.
Right. So we lost Ben.
Ben, you're muted if you're trying to talk.
And his camera's off. Oh, now I'm by myself. Yeah, everybody, if you haven't checked out Faraday Research, I've got over 1,000 videos on my YouTube channel. You can check that out. Also, become a member of the Faraday Research YouTube channel. I think it's like $3.99 a month, and you got thousands of hours of live shows and videos and build videos, and I've done so many experiments. I can't even count that high.
Countless, even in the last 5 years that we've been. So just since I've known you, it's crazy, and it was like I was stunned on everything that you had done prior to that, because just wild. And sign up to Faraday Research, Patreon, and members.
I think the most views I got is on the End Machine build, and also the Gerard Morin mechanical inverter with the washing machine motor, pump motor. Turn that into an AC power source, and that worked really good. That build was
whatever happened to that? Do you still have that build?
Yeah, it's in my lab. So
nice. We got to develop and work on that and show that some more, because the Gerard Morin designs, it's pretty wild, and that you've replicated one of them, right? Like he had to disappear to China.
Well, he was trying to build his big unit in China. He was trying to get the proper motor control for the drum motor. He had to get a certain amount of high voltage RF out of the drive controller in order to get the RPM he needed to run the generator. So he was going to different companies trying to get them to build the motherboards and all the electronics to run that motor properly.
If I remember correctly, they did end up building everything properly. Originally, he was able to source the parts all in China to Canada, but then FedEx to the government customs destroyed certain pieces when they arrived. So then he actually had to go to China and do it all over again to actually be able to build it and demonstrate it. It hasn't been heard of since.
Yeah, because I knew he had a lab there in China, a group of guys he was working with there. And he also had another lab out in Australia, because he's Aussie background, right? but he lived in Vancouver as
No,
far as I know.
he's not. No. He's not Aussie, and he's not from Vancouver. He's from Montreal. He's Quebec. He's a Quebecois.
Oh, are you sure we're talking about the same? Because there's two
Jared
Gerard Warrens.
Jared Warren with the washer machine. Yes, sir.
Are you okay? Because I understood.
I know
he
the
was
other
from
one you're talking about too. Ben, if you're trying to talk, brother, both are muted. We can't hear you.
Yeah. Yeah, he's muted. No, I can't. Yeah, his mic is not connected. Don't know. You know what? I'm gonna remove him and see if he can log back in. Maybe that's the problem. Oh, we have Lulu.
Lulu,
Hi.
Lulu, how you feeling?
how are you, sister?
I'm feeling a bit better. So I didn't want to not come and say hello to everybody.
Well, we're glad you're feeling better and that you're able to say hello. It was lonely without your female balancing presence.
Yeah. Yeah.
I apologize and thank you.
No. Hey, if you're not feeling good, you shouldn't just take the night off, Lulu. You know, there's always another day.
Yeah.
Right.
So
But thank you for showing up.
Yeah, I missed most of it, but I'm sure it was a great show.
Yeah. Well, relax. Take the night off, and it's not like you're getting paid to do this. So you're coming on.
I
your own
know,
free
I know,
will,
but
right?
it's like it's not about getting paid. It's about like the whole, being connected with my friends at least once a week.
We're a
Yeah.
team.
Yeah.
That's what it really
It's the
is.
community. It's I get it. Yeah, I get it. Yeah, for sure. But just a program note for everybody. I won't be doing a show next Friday. My wife's getting a surgery, so I have to attend to her and make sure everything's good with her. So hopefully it'll just be 1 week I have to take off. I might have to take off a second week. I don't know. It all depends on her recovery. So so just play it by ear and wait for any updates at the Fairday Research YouTube channel. But as of next week, I won't be doing a show next Friday. So that's pretty much. I don't know, Bernie. If you want to run it,
if I make it back to Nathan's by Friday, I'll do it from his place.
We hope she has a speedy recovery. We wish her well.
Successful surgery.
Take that care of that first. Yes.
Yeah.
Praying for her healthy recovery.
Yeah, she'll be way better off since she gets it done. So, this year has been really hard on her. So, sooner the better. She's been on a waiting list since like October last year. So, ridiculous waiting. So, it's got to be done, and her life will get better after that. So, that's Monday we're gonna be at the hospital.
Start making the structured water, Mike, and start feeding it to her.
Yeah, I got my machine, so So what else we want to do here before we call it a night?
I finally got my magnetic paper.
Oh, you got your magnetic paper in?
Yeah.
Heck yeah.
Here, let me show you guys. This is fun. Magnets.
Oh yeah, I got that too. Yeah.
All right.
So you can see the field.
Yeah, but some magnets have weird fields. So look at this.
Oh, absolutely. The Dr. U fields.
All right. Look what it makes. Do you see it?
Yep.
Okay. So that's the shape of the field. Huh?
Mike, can you highlight Lulu's?
Yeah. Yeah, it's making, you got the field around the outside diameter, and then on the inside diameter, you also have a field. And that's part of the reason why when you do a Howard Johnson motor, you get it locks up. You got that sticky spot, right?
Yeah, but it has really cool shapes.
Coming off, two like spike horns coming off it.
I didn't want to say it, so you did, but I did not want to say it, but it does look like that.
The horns are coming off.
All right. So this is like one side. This is the other side. It has I don't know if it has the same shape. See, it's a different one.
Yeah.
What?
All right. Here's a different magnet.
Because Ken Wheeler was talking about that, and most of the flux energy is coming around the outer diameter of the magnet itself, and then you have that gap or that cancellations in the middle. That's kind of weird.
Ooh, I just had a crazy idea. So it's like, what happens when you start coding on like certain sides or areas of those magnet geometries some bismuth diamagnetic with the fields, right?
All right, well, let's see how this one looks like, because it's a sphere, so it's really hard to, I guess, imagine it. What the magnetic field would be.
See the fields on the outside of the magnet, not in the middle of the magnet. See? That's where the cancellation zone, or basically the collapse of the dielectric acceleration.
Yeah. So you can't see it here, even if I hold the two ends.
Yeah. See, who used to do this a lot with magnets? Joe, the guy who made the Joe cell. Because he made a magnetic device with a pipe, all right? And he's got magnets over the pipe. He'd run dirty water through one side, and he would have clean water come out the other side.
Yeah. See, this one, I don't know if you can see.
I see the reflection of me in there.
Oh, yeah.
Yeah.
But yeah, I've been playing with this one. So, oh, look at this one too. Cell phone. But you can see the magnetic field.
Oh, yeah.
Cool, huh?
Right.
Isn't it like this side? See? Cool. Yeah. So.
That's cool. Yeah, I got the magnetic thing on my phone as well. See? I got the magnetic thing on my phone.
You know what it's cool to be used for? Like to hunt for magnets between broken devices. Like to see what lights up.
Yeah.
Yeah.
Huh.
What are you showing us?
Yeah, BurnEye? I'm looking at BurnEye is showing some of the archives of
yes. Sorry, I was muted there. I was trying to unmirror my screen so it's not reversed, but these are called the Electric Spacecraft journals, and they run from the early. So this one's issue 11 from 1994, and I think they went to. This one's 2003, but I'm pretty sure I saw some that were up to like 2010. Anywho, point of it is it's pretty crazy stuff. High potential alternating E field electrostatic charge transfer, evidence of scalar longitudinal waves, neon sign transformers for the researcher, the speed of gravity, fireball production from testicles. That episode. This is pretty intense because you have this plasma field reactor, and doesn't that like look like a guy or a ghost with like the head, the shoulders, the arms, and then somewhat of a body jet? But no, that's actually plasma field, and it's structuring just like the RAV that demonstrated and been working on by Sean Calderon, Nathan, Old Man Bills, and Joe there. And it's the exact same build out of the RAV formation in this plasma field from this. But we have interference patterns in electrostatically contained plasma. So that's what that is. And then we have a thermodynamic cycle to heat electrical energy conversion by means of ferroelectrics, plasma displays, and inert gas discharge tubes, flyback transformer, electromagnetic project, inverse Doppler effect, dusty plasma. ESA conference summary. Fuser neutron generators, red and green energy, Hertz equations of electrodynamics, electric field propulsion, concepts from independent researchers. We got Tesla electrostatic plasma balls, the Wilmshurst generator for high energy research, electric propulsion research at Princeton, toroidal spark gap engine tests. And so these were just additions that Steve still had multiples of, so I was able to get them, but he has the full sets of all of these, and it's wild. There's so much information that's been covered up and classified over the years, but people have been working on it forever.
Yeah, awesome.
How are you going to end up transferring all this information into like a something that people could actually search for? See, now you're like
digitizing
video.
and uploading it to the internet is what we're going to be doing with the archives.
Yeah, but like to turn it all into document style, so people can see it. Other than
PDF.
so really they can read the information truly.
That's exactly what he's doing. He's got a scanner that automatically puts it into PDFs, and the archives, everything that's already been digitized, is up on www.teslatech.info. Is the Tesla Tech website, and he does have the PDFs and the archives up on there.
Very good.
Yeah, it's crazy. It's like for one person, it's like 1,000 years worth of information, but for humanity, it's what we need everyone to be working on and acknowledging, because it's all here. Entropy of polarized medium depends on the temperature and the applied electric field. Therefore, the empty differential is composed of two partial derivatives, and then the equations, which can be written as, since ds is a total differential, the identity must be like it. It's all here. It's crazy. Princeton study on that one. Plasma stays in their gas tubes. Ooh, that's always fun.
I just had something really weird happen.
Ooh, okay.
This is my phone has wireless charging. I had 71% at the beginning of the show. I got 91% now. I don't have a wireless charger near me.
Ooh, that's interesting. That's wild. What do you have working on there? Do you have anything running around?
I only have my power cells near me.
Just so wow.
Mike, do you not think that the information that comes out of the show is like space-time engineering other data, because it holds a primary relevance in new sciences, so it's always going to take top tier.
Well,
so you're
put it
going to have
this way, like all I have with me right now is a mouse, my computer, some food, and my power cells are about 2 feet away. There's nothing here to charge this phone.
Okay. How would you believe in teleporting physical state and energies from one receiver,
Sure,
to
you can, yeah.
Okay,
so
we're
the wireless
connected.
receiver built into the phone, right? Already, and that it's his power cells are putting out the electric field for it to.
I only have 71%.
Okay, I have a bunch of magnets. It's pulling from the atmosphere. It's interfering with the iPad. Science. Listen, all possibilities are possible until proven otherwise.
Absolutely.
Yeah.
I don't know where the power came from. I got no wireless
charger.
Do.
Yes, we do. It's the field being put out by your power bank battery systems. Clearly.
Yeah, it was at the beginning of the show. I was looking at it, It was 71%. I got 91 right now.
So what you need how to experiment with that, Mike, is don't plug your phone into a charger. Don't unplug your normal wireless charger, and then just rest your phone on top of those.
I don't own a wireless charger.
No, he's telling you
I don't own a wireless
saying
charger.
since
don't
the
charge
show's
it normally, and just keep your phone on top of those battery power banks and see if it keeps it charged.
No, it's about the information field that's being cycled through the device because it's going live. Do you understand? The show is live, so the telecommunication has to be at the speed of whatever in bandwidth and
Well, I'm using my laptop to run the show. Like,
so
my
there
cell
is a
phone's just
field.
sitting
Not
on the
on the
side.
phone.
Like,
There's a
I'm
high
not
energy
running it on the
field.
phone. I never seen this happen before. This is really odd. This is really, really weird.
Yeah, it is.
It's gone up 20% since I did the show. I started the show. I don't have a wireless charger at all. I don't own one. So how can it charge on its own? Like,
some sort of static electric field obviously is that it's immersed in that you're creating or having put in your area, right? So I'd say just keep your phone very close to your power bank.
There, hold on. I gotta show this. This is what Elijah's saying. Your body is the wireless charger. When displacement current density is there, stop touching it and put it on. It has been. It's been sitting on my wood table the whole evening.
So you haven't been holding it or touching it at all.
No, it's been sitting on my wooden kitchen table. I haven't been touching it at all. And I don't own a wireless charger. I don't have one.
Well, consider yourself lucky. Accept the gift. And that's
my phone does have wireless charging, right? But I don't have a wireless charger. I only have the wired one, and that's in my bedroom. So it's just sitting here basically on its own on the table here doing nothing all night. And now I got 20% more power than when I started at the show. Beginning of the show. That's
fascinating.
Harnessing atmospheric energy.
I'm just electrifying. I'm emitting my own biofield energy, and I'm charging my phone. Maybe I am. Maybe I got so much electrolyte in my body.
I don't know.
I still think it's the transmission of information through the matrix, creates an energy field. A high energy field.
So apparently I can create and manipulate magnetic fields and an inverse Doppler effect with my metamaterials. Interesting. Oops, sorry, I didn't realize I was the camera.
Yeah, that's right. Both per meter. Yeah, my Renegade. Yeah, Elijah's asking me if I still have the MPN. Yeah, I have it, but I don't have anything hooked up right now. That would be interesting. Yeah, turn that on, and then put my phone next to the coil. It probably would start charging it.
That's what I'm saying. You should experiment with it and see if it does.
That's a whole other thing. Experiment to carry on tonight or tomorrow.
Right?
Yeah, just gotta be careful. Yeah, I have the MPN.
Just don't make the results public if they're very successful. Just share with us, right?
Yeah.
Might not ever hear about this again until Mike Security has a $1 billion patent, right? Or disappears forever.
What's that?
You're either gonna get like millions or billions of dollars of contracts out of that mic, or you're just gonna get disappeared, right? If it's
maybe, yeah.
very successful.
Okay, I'm making it public now. I am not suicidal. Okay, I never will commit suicide ever. So if I disappear,
Yeah. I would like to also reiterate the exact same. As always, we love life, we love being alive, and yeah, we are all healthy individuals and in perfect mental health.
all right, guys, I think we're going to square it up for the night. I want to be able to cut this video down and make some shorts out of it. Do my usual thing. Everybody, thanks a lot, Lulu, Mr. Ben, Bernie, Mr. Phillips already gone, but thanks to the cast tonight. Hopefully we'll be back on in 2 weeks from now. And yeah,
we all pray for your wife's surgery to go well next week and have a speedy, quick recovery. God bless.
Thanks. Yeah, thanks everyone for your kind words, and we'll see everybody hopefully in 2 weeks. All right, take care for now.
Bye.
Bye.
Take care.